Hey guys, this is Worm from Worm's Maths Academy. Just thought I'd let you know that I'm going to go through 2021 Exam 1. I have done this previously, but I did it rather quickly, and I thought students from the years following this might want me to go through it with a bit more explanation. So, the first one, differentiate this. We know if we have y is e to the ax, dy dx is ae to the ax. So in this case here, we get dy dx. We bring that -3 down to the front and multiply it by the 2. We get -6e to the -3x. Okay, second one. We've got to find the derivative of this. So let's say u is equal to x, v is equal to 2x plus 1 to the half. Of course, this is a product rule question because we've got a product of two functions. U dash is 1. V dash, we've got to use a chain rule here. We bring our half down to the front, multiply it by the derivative of the bracket, multiply it by the bracket, and subtract 1 from the power. Now they cancel each other out. Well, they equal 1. So we get 1 over root 2x plus 1. Okay, now we know the product rule, f dash of x, we cross these and we cross these. So we get root 2x plus 1, this here, plus x over root 2x plus 1. And then we've got to sub in 4. So if I sub 4 in, I get root 9 plus 4 over root 9, which is 3 plus 4 over 3, which was 13 over 3. So we had a product rule, and inside the product rule we had a chain rule. A little bit different to what they've done in the past. Okay, here we've got a derivative. F dash of x is x cubed plus x. So we can say f of x is the integral of x cubed plus x dx. When we anti-diff it, we get x to the 4 on 4 plus x to the 2 on 2 plus c. We know f of 1 is 2, so we can say 2 is 1/4 plus 1/2 plus c. We get 2 minus 3/4, so we get 5/4. So that tells us that f of x is x to the 4 on 4 plus x squared on 2 plus 5 on 4. Okay, this one here, we're told that we've got a function 2 sine 2x and it asks for the range. We can say g is an element of -2 to 2 because we know the lowest value for a sine graph and the highest value for a sine graph is based off the amplitude. We know that our period is 2 pi over the coefficient of x, or n. So our period is pi. And then here, they want us to give a general solution because it asks for all real values. So we know 2 sine, we can bring the 2 over to the other side. We get sine 2x is equal to root 3 on 2. We use a special triangle 1, 2, root 3, pi on 3, and pi on 6. Now, if we know that sine is opposite over hypotenuse, if that's opposite, that's hypotenuse, my base angle is pi on 3. So we can say 2x, we know that sine is positive, because here it's positive, in both the first and the second quadrant. So we would get pi on 3 and 2 pi on 3 as our solutions. However, we know because it's a general solution, we've got to add 2k pi to both of our solutions and state that k is an element of z, because k has to be a multiple, or k has to be an integer, because 2 pi has to be a multiple of an integer to get the next set of solutions. We can then divide the 2 to the other side, so we get pi on 6 plus k pi. We get pi on 3 plus k pi. K is an element of z. It's important that you write this, because if you've got one solution, to get to the next one, you've got to either add a multiple of 2 pi, or you've got to subtract a multiple of 2 pi. Now, of course, that changes when we divide by 2, because we're halving the period, so we've got to add a multiple of pi. But that's our general solution. Okay, this one here, well, we know x, if x is equal to 2, we've got a vertical asymptote. So we put that in there. Remember to look at the scale. Don't know why that didn't draw that for me. And then we've also got one at 1. Y is equal to 1. Don't forget to label them. So y is 1, x is 2. We know if x equals 0, we get y is 1 minus 2 over negative 2, which is 1 plus 1. So we get y is 2. So 0, 2. We know it's a hyperbola that's going to approach those asymptotes. And we know by symmetry, if that goes through 2, because from this point here, it's 2 to the left and 1 up, we can go 2 to the right and 1 down, and we know it's also got to go through 4. Okay, so that's the point 4, 0. Okay, label asymptotes with their equations, axis-intercept with their coordinates. We've done everything. Okay, find the values of x for which 1 minus 2 over x minus 2 is greater than or equal to 3. So there's 3. We want these values here. So we need to see, when does that equal 3? 1 minus 2 on x minus 2 is 3. If I bring my 3 to the left and the minus 2 on x minus 2 to the other side, we get negative 2 is 2 on x minus 2. If we switch those two, we get x minus 2 is negative 1. So we get x is equal to 1. So that's when it's first equal to 3. But we want to know the x values, for which it's greater than or equal to 3. So we know it's x is an element of 1. We can include 1 to 2, but we can't include 2 because it's never going to get to. It can't be 2 because it's an asymptote. So it's approaching that value, but it's never actually going to get to it. Okay. These two graphs have a common horizontal x-axis intercept, 2, 0. It says find the coordinates of the other horizontal axis intercept of the graph of G. So we know one of them is 2, 0. We can say g of x is equal to 0. Therefore, 4 x minus 1 squared minus 4 is 0. We can bring the 4 to the other side and divide it by 1. X minus 1 squared is equal to 1. X minus 1 is plus or minus 1 when I square it the other side. Therefore, x is equal to negative 1 plus 1, 0 or 2. Now it says find the coordinate. Therefore, the other x int is 0, 0. Because we already know the 2, 0, 1. Okay, let the graph of H be a transformation of the graph F, where the transformation has been applied to the following order. A dilation of factor half from the vertical axis, so the y-axis. So if we dilate a half from the y-axis, that's f of 2x, which would mean that we'd get 2x squared minus 4, which is 4x squared minus 4. Translation of 2 units to the right, which would give us 4x minus 2 squared minus 4. So we can say that h of x is 4x minus 2 squared minus 4. State the rule of h and the coordinates of the horizontal axis intercepts. So these two graphs are very similar. However, this graph has been translated one more unit to the right. So therefore we could say x-axis intercepts. I don't know why they've said horizontal because it's stupid. Because then you have to write horizontal axis intercepts. Like, what a waste of time. So we know if we translate this one to the right, we get the point 1, 0. And if we translate 2, 0 to the right, we get 3, 0. Okay, an online shopping site sells boxes of donuts. A box contains 20 donuts. There are only 4 types of donuts in the box. They are glazed with custard, glazed without custard, not glazed but with custard, not glazed with no custard. So here, hopefully you guys can see that we're going to need a Kano map. So what do we know? Let's move this one a little bit that way, this one a little bit that way. Okay. One, two, three. So we can have glazed, we can have not glazed, we can have custard, we can have not custard. It's known that 1/2 of the donuts in the box are with custard, 7/10 are not glazed, 1/10 are glazed with custard. So 1/10 are glazed with custard. Half of the donuts are with custard, so let's say that's 5/10, just because it's going to be easier to add up. 7/10 are not glazed, so 7 out of 10, which means 3/10 are glazed. So we know that's 4/10, we know this is 2/10, and we know this is 3/10, and it adds up every way. It says a donut is chosen at random from the box, find the probability that it's not glazed with custard. So the probability that it's not glazed intersecting custard is 4 out of 10, which is 2/5. Okay, The 20 donuts in the box are randomly allocated to 2 new boxes. So box A and box B. Each box contains 10 donuts. Of the 2 new boxes, one of the 2 new boxes is chosen at random, so there's a half a chance of each one. And then a donut from that box is chosen. Let G be the number of glazed donuts in box A. So box A, okay. So we know we've got glazed, not glazed, glazed and not glazed. We know that G out of 10 are glazed. So 1 minus G out of 10 and not glazed. G out of 10 are glazed, so 1 minus 9 G out of 10 and not glazed. We also know that the amount of glazed donuts is 3 out of every 10, which means that 6 out of the 20 are glazed. Now, if we know that the amount that are glazed is G, we know that the amount that are left over in the other box are 6 minus G over 10. Because G is the amount in one box and there's 6 in total, so we know 6 minus G on 10 will be how many are in the other box. And then we know 1 minus 6 minus G over 10 is going to give us how many of them are not glazed. So that's going to give me minus will give me G. That's 10 over 10 minus 6 over 10 is 4 out of 10. So we've got G plus 4 over 10. Now with something like this, I would test it. So I would say let G equal 2. So if I had 2 in here, I'd have 2 out of 10 that are glazed and 1 minus 2 out of 10, 8 out of 10 that are not glazed. If we go to the second one, glazed, we've got 6 minus 2 over 10, which is 4 over 10. So altogether, glazed, we've got 6. And then if I put 2 into the second one, I get 6 over 10, which means I've got 4 over 10, 6 over 10, which is 10 over 10, 2 over 10, 8 over 10, which is 10 over 10. So we know this must be correct. Now it says find the probability in terms of G that the donut comes from box B given that it's glazed. So the probability that's from B given that it's glazed. So that's the probability that it's from B and glazed over the probability that it's glazed. We know that B and glazed is this times this, which is G over 20. That's divided by the probability that it's glazed, which we know is G over 20 because from box A and glazed, or it's from box B and glazed, which is 6 minus G over 20. Now, if we add these together, they cancel. So we get 6 over 20. So we get G over 20 divided by 6 over 20, or we could say times, buggered something up here. We add them together. g over 20 plus 6 minus g over 20 oh, that's not g over 20. That is a half of 6 minus g over 20 because I want it from box B and glazed. So we have got 6 minus g over 20 divided by this, which is 6 minus g over 20 times 20 over 6. The 20s cancel, so we get 6 minus g over 6. So the probability that comes from B, given that it's glazed, and that should make sense as well. If I had two of them, I'd have 6 minus 2 over 6. So if we know that it's glazed, the probability that it came from B is going to be 4 out of 6, which is 2 out of 3. It should make sense. Okay, the online shopping site has over 1 million visitors per day, so it's a large population. It's known that half of these visitors are less than 25. Let P hat be the random sample representing the proportion of visitors who are less than 25 using a sample of 5 visitors. So N is 5, P is 0.5, or we could just say a half of the visitors. We want to know the probability. We could say X is binomially distributed, 5 and 1/2. The probability that P hat is greater than or equal to 0.8. We know that P hat is equal to X over N, so N times P hat is equal to X. So we could say X is equal to 5 times 0.8, which is 4. So this is the same as the probability that X is greater than or equal to 4. Now we know with the binomial distribution, we've got 5 choose 4, a half to the 4, a half to the 1. 5 choose 5, a half to the 5, a half to the 0. Anything choose 1 less than itself is just itself. So I've got 5, I've got a half to the power of 2, which is 1 on 32, plus 1, anything choose itself is 1. A half to the power of 5 is 1 on 32. So we've got 5 on 32 plus 1 on 32, which is 6 on 32, which is 3 on 16. So we can say the probability that P hat is greater than or equal to 0.8 is 3 on 16. Okay, K on X squared is defined between 1 and 2. We want to show that K is 2. So if it's a PDF, we know that if we antidiff from 1 to 2, kx to the negative 2 dx, that it will equal 1. If we add 1 to the power and divide by the new power, we'd get kx to the negative 2 on negative 1, which is negative k on x between 2 and 1 is equal to 1. If we sub 2 into here, we get negative k on 2 minus negative k on 1 is equal to 1. I get k minus k on 2 is equal to 1. 1 minus a half is a half. So we get k is equal to 2. Find e of x. So we know e of x is from 1 to 2 of x times f of x dx, which is from 1 to 2. If I multiply x by 2 on x squared, I just get 2 on x dx. If we antidiff 2 on x, we know that's just 2 log e of x between 1 and 2. If I sub 2 into the first one, we get 2 log e2 minus 2 log e1. We know that's just 0, so our answer is 2 log e2. You could also put log e4. They're both the same. Okay, question 8. The gradient of a function is given by this. The graph has a single stationary point at 329 on 4. Find the rule for the function. So we know we can say y is the integral. I'm going to change that to be x plus 6 to the power of a half minus x on 2 minus 3 on 2 dx. Now, hopefully you remember, if you want to antidiff ax plus b to the n, it's 1 on a times n plus 1. Ax plus b to the n plus 1 plus c. So in this case here, we get 1 on, our new, a is just 1, and our new power is 3 on 2. So I get 1 divided by 3 on 2, which is 2 on 3, x plus 6 to the 3 on 2, minus x to the squared on 4, minus 3x on 2, plus c. We know when x equals 3, y equals 29 on 4. So we get 29 on 4 is equal to 2/3 the square root. If I sub 3 into this, I get 9 cubed minus, if I sub 3 into that, I get 9 on 4. And if I sub 3 into that, I get 9 on 2 plus c. We know that this, the square root of 9 is 3. 3 squared is 27. If I multiply 2/3 by 27, I get 18. So I'm going to say c is equal to 29 on 4. If I bring this 18 to the other side and put it over 4, I get 72 on 4. If I bring the 9 on 4 to the other side, I get plus 9 on 4. And if I bring the 9 on 2 to the other side, but put it on 4, I get 18 on 4. Now, if we add these together, that's 27 plus 29 is 56. 56 minus 72 on 4 is negative 16 on 4, which is negative 4. So our end equation is y is equal to 2 on 3, x plus 6 to the 3 on 2, minus x squared on 4, minus 3x on 2, minus 4. Now, it says find the rule for the function. So you could debate, oh, we should give that a domain. It would be x is greater than negative 6, but I don't think they want you to do that. But later on in the question, they ask for the rule for the function, and they may want you to do it. So it's really frustrating with VCAA when they don't say things explicitly. Now it says determine the nature of the stationary point. So we know we've got the point 3. So we'll create a gradient table. No, actually we won't use 4. We want to choose a better number. 10. X, dy dx. We know when x is equal to 3, the gradient's 0. If I put 0 into here, I get root 6 minus 3 on 2. Now root 6 is greater than 2, so this thing is going to be positive. I chose 10 because if I put it into there, when I square root it, I get root 16, which is 4, minus 10 over 2, minus 3 over 2. So I've got 8 halves minus 13 halves, which is negative. So we also know that's negative. Now that tells us the stationary point is a local maximum because it's got that shape. So it's going up to a local max. It's also an absolute maximum. Okay, so we're nearly there. Question 9, it says we've got the unit circle x squared plus y squared equals 1 and the tangent to the circle, the point P, is shown in the diagram below. So it's just touching there. We know this length here is 2 and this length here is 1. We could use Pythagoras' theorem and work out that length if we wanted to. So show that the equation of the line passing through the points A and P, so this equation here, is given by that. Okay, so first thing we can do is we can say theta is there, because we know this side here is 1, and that's 2. So we can say sine of theta is equal to a half. We know if sine of theta is a half, then our angle's pi on 6. So theta is pi on 6. If we want to find the gradient around here, or like if the angle there is pi on 6, we know the angle around there, let's call it alpha. Alpha is 5 pi on 6. The gradient is equal to tan of the angle produced with the positive x-axis. So it's tan of 5 pi on 6. And we know if we've got tan of pi on 6, tan is opposite over adjacent, and it's negative because it's in the second quadrant. Okay, so first, we know m is negative 1 on root 3, just root 2. X is 2, y is 0. We know y is equal to mx. So sometimes VCAA also wants you to rationalize, but then when they do it here, it's not rationalized, which is contradictory. X minus 2 plus 0. So we get y is negative x on root 3 plus 2 on root 3. Okay, it then says, let the transformation for all x and y values, where we have a dilation from the x-axis q, where q can be any real number except for 0. And let the graph of h be the transformation of the line that passes through those points. So we're getting this line, and we're dilating it from the x-axis. So that point will always stay the same, but this will move further away, or it could come closer, or it could go to the other side because it could be negative. Now, find the values of q for which the graph of h intersects the unit circle at least once. Find the values of q. So if q is 1, it's going to go through there. If q is a half, it's going to go through them. If q is 0, can't be 0, because in the question it says it can't be 0. But we know by symmetry, if that's when q is 1, it touches it once, and that's when q is negative 1, it can be all values. So q can be any value from negative 1 to 1, with the exception of 0, because in the question it told us that it can't be 0. If q was 0, you'd end up with a straight line, and that would pass through it twice. So I don't know why they didn't let it equal 0. Okay, let the graph of h intersect the unit circle twice. Find the values of q for which the coordinates of the point of intersection only have positive values. So it can't be there because that's only touching at that point. But if q was here, that coordinate has positive values, but this one has a negative value and a positive value. So that one is no good. So we can start it from here, and then we can go up to this point here. But we can't include this point because the x value would be 0. Now, how do we get this point? Well, we know if the y value is 2 on root 3, we want the y-intercept, we want this to become 1. And the way that we would do that is multiply it by root 3 over 2, because we know that will equal 1. So if we dilated it by factor root 3 on 2, it's going to look like that. And it's only going to have positive intercepts, but it can't equal root 3 on 2 because it can't include that point because it has to be positive. So we know q would be, we know that's 2 on root 3, so it'll be from root 3 on 2 up until 1, but it also can't include 1 because it says it intersects the unit circle twice. So like anywhere in between those values, it's going to touch twice. There, it's only going to touch once. There, it's going to touch twice, but that's both positive. That one's 0 and positive, so we can't include that. So q is between root 3 on 2 to 1. Now for 0 is less than q, which is less than 1, let p dash be the point of intersection of the graph of h for the unit circle, where p dash is always the point of intersection that's closest to A. So here, we've got 2 points of intersection, but P dash is the one that's closest to A. So let's see, if I made P dash go over here, we couldn't actually have P dash over there because there's a closer point of intersection, so that would be P dash. If I made the graph go through over here, P dash would be that point there. So there's a point where P dash would stop, and that's when it's perpendicular, because once we get to here, we know any point past here, it's going to intersect twice, and this one's going to be the closer point. If I went to here, it's going to intersect twice, so this one's going to be the closer point. So the furthest point away would be that point there. And that's also going to be the maximum area. You can see just by looking at it. Now, what is that value there that makes that occur? Well, previously we found up here that that was pi on 6, and that's 90, so this has to be pi on 3. Okay, now it asks us to find the function g, which is the area of this. Now, to find the area of a triangle, we know that's 2, and we know that is 1 because it's a radius and that's the base. In this case here, we know the area of a triangle is a half AB sine C. Although that's not a formula that we use in methods, which sucks because that's 2 and that's 1, and theta is there. Okay, is there another way that we can find that height? We know that's 1, so we can say sine of theta is h over 1. So h is equal to sine theta. And we know the base length is 2. So the area is a half times 2 times sine theta. So either way, we get exactly the same answer. Now, this is worth 2 marks, and it says to define the function g. In this case, they may want you to say what the domain is. But this is what I was talking about before, when up here it said to define a function. I'm pretty sure, where was it? Back here. With that one, find the rule for the function. They don't want you to give the domain. But with this one here, maybe they do. So we know g of theta is a half times 2 times sine theta, which is just sine of theta. And we know that theta is between 0 can theta be 0? It can't be 0 because then q would be 0. And q can't be 0. So theta, 0 is less than theta, which is less than or equal to pi on 3. Okay, now determine the maximum possible area of the triangle AOP. So the max area occurs when theta is equal to pi on 3. Like you can see clearly that it's pi on 3. Therefore, g of pi on 3 is sine of pi on 3, which is root 3 on 2. Therefore, the maximum area is root 3 on 2 units squared. Okay, now some people say, oh, that's a really easy exam, but there's plenty of spots that you can make mistakes on it, like plenty. So, people are saying, you've got to get a really high score to get this and this a mark. It's kind of, I don't think it's as easy as what everyone's making it out to be. You could stuff up quite a bit. Okay, if you did that exam, hopefully you did well. Hopefully I'll get my hands on exam 2 and get through that as quickly as I can tomorrow. Best of luck for the rest of your exams, especially the special kids got them coming up. Bye.